Today, we will be investigating eDNA and sampling a small pond in Mequon, Wisconsin. The pond that we are sampling is found in southeastern Wisconsin in Ozaukee County. It is located in the Milwaukee River Basin and in the south branch of the Milwaukee River subwatershed. All of the major watersheds in the Milwaukee River Basin are a part of the Great Lakes-St. Lawrence River drainage. In the greater watershed, species such as trout, some stocked salmon, northern pike, walleye, and smallmouth bass are present. It is also home to some native grasses and amphibious species. There are 18 miles of trout streams, 875 river miles in total, and 403 miles of impaired waters. However, this area is one of the most densely populated areas in the state, and there is great concern over water quality. The Milwaukee River has been dealing with concerns over conductivity and turbidity, great amounts of nutrient runoff, phosphorus contamination, bacteria, and algal blooms. In a 2019 report authored by the Milwaukee River Keeper, the basin was given a D+ overall rating for water quality. The pond I chose is far too small to be able to host any large fish or great amounts of biodiversity. However, I am curious if the plant life and algae concerns that plague the basin are reflected in the pond. Despite having moved to the neighborhood when I was 5, I have only vaguely been aware of discussions concerning its water quality. I am vaguely aware of there being algae issues in the pond and know that the neighborhood has instituted chemical treatments. However, I am sure this was done for aesthetic purposes and out of health concerns for the neighborhood dogs who might swim in the ponds. I do not know if anyone has looked into the small ecosystem of the pond itself. That said, despite the chemical treatments, I have noticed some neighbors fishing and have noticed waterfowl are common. With all this in mind, I figured I would employ an eDNA test kit to see if 1. The chemical treatments were successful, and 2. If any species were left unidentifiable. The first step of the eDNA kit is to draw the water for the sample. First, we will put on gloves. Then, we open a sterile syringe provided in the DNA kit. Water must be drawn into the syringe before the filter can be placed. We will draw up 60 milliliters of water, which I am doing close to the shore of the pond. Lucky for me, I have my very fluffy and cute lab assistant to supervise. Once I have my 60 milliliters, my next step is to attach the provided filter and push the water through at a steady pace. The filter will trap what is floating in the water of our sample, so we are aiming to clog the filter to where the water can no longer be pushed out or until water is being excreted at about a drop every 2 seconds. If this does not happen on the first pull, we can take another 60 milliliters of water and repeat the process until it clogs. However, I did not have to do so. Next, we push air through the filter to dry it out. Now we've completed the collection portion of our eDNA kit. Next, we'll work on packaging our sample and sending it off. We've already saturated and dried out our filter, so the next step is to apply a preservative so the sample can make it to testing. We'll screw our large syringe that we used for water collection off of our filter, and then we'll screw on our syringe with preservative from the kit. We'll then inject the entire 1 milliliter of preservative into the filter. Once this is done, we screw off the syringe, screw on 2 lock caps on either side of the filter, and place the whole thing in the foil bag provided in the kit. We can also stop for a treat to reward ourselves for all the hard work so far. Now, very importantly, we have to document our sample collection. We can go through the Jonah Ventures app and type in all the necessary information, including the code of the sample kit. Each foil bag has a sticker on it with a typed out code and a handy dandy QR code which you can scan into the Ventures app as well instead of manually putting in the info yourself. If you give your phone access to location services, it will also fill in your latitude and longitude. I opted to make the results of my test kit public. Once we submit our sample, we put our tin bag into the prepaid postage bubble envelope and we send it off to the post office. Unfortunately, I have not yet gotten my eDNA test results back. However, I was able to find the pond treatment records to gain a bit more insight. The pond that I tested is referred to as Pond B and the South Pond in these reports. There are 4 reports total, spanning June, July, and August of 2021. In these reports, the ponds are repeatedly treated for planktonic algae, sago pondweed, and what one report refers to as organic muck. Based on these findings and what I could visibly see in the pond, I speculate that I would find 3 primary species. I would expect a type of planktonic algae, as noted in the documents, although I am unsure if it would be cyanobacteria or a different species. I would also anticipate Stachenia pectinata, which goes by its common name sago pondweed, both from the reports and personal sightings on the pond. Furthermore, sago pondweed is a common food for waterfowl, and ducks were feeding on the pond as I was collecting my sample. Finally, I would potentially expect to see DNA from these mallards and S. pletyrhynchos in the sample, granted that they shed enough DNA to be picked up by the test. I have also seen common toads and turtles in the neighborhood and can sometimes hear the frogs at night. I believe the turtles are Chrysamis picta, the painted turtle, which are one of the most abundant in the state. I'd also suspect that the toad species is Anaxyrus americanus, the eastern American toad, which are found throughout the state and have a call similar to what I am able to hear. That said, I am unsure if these species would be captured by the eDNA and would say it is less likely.